Hi everyone, I'm Cheryl. In this problem, we're asked to find the fluid force of water as it pushes against the side of a tank. And the side of the tank has the shape of a parabola that is 4 feet across the top and 4 feet deep. In this particular problem, I want you to notice that the pressure is going to be a variable force. Because if you think about it, the pressure is greater as you go deeper underwater. And the water at this level will be deeper than the water that's up at this level. So we're going to need an integral to evaluate this fluid force. Okay, well the first thing I did is I went ahead and I put a Cartesian plane on my picture. Now I oriented it so that the origin was right at the bottom of that tank. You really could orient the Cartesian plane anywhere you like. It's going to change the formula a bit, but the final answer will be the same no matter how you put that Cartesian plane on. All right, well the way I've done it, I've put my parabolic shaped side of my tank right in this location, which means the equation can be written as y equals x squared. Okay, so what I'm going to do is I'm going to look at a representative element. So I'm going to take just a piece of this side of my tank. Okay, and let's see if I can figure out what the fluid force is just of that little piece. Well, I know what I have to do. I have to take the weight density. I'm filling this tank with water, so the weight density is 62.4 pounds per cubic foot. I also need to measure the depth. Now, what is the depth? Well, in this particular problem, the distance from the x-axis up to the top of my tank is 4. So this depth can be represented by y. So I'll have 62.4 times 4 minus y for my depth. The area is going to be the area of this representative element. Well, it's a little rectangle, so it's the length times the width. Well, the length is going to be a horizontal measure, and that's going to be twice the x-coordinate of that point. And then I'm going to multiply by the width. The width is going to be a change in y. Well, because this is measured in terms of x and this is measured in terms of y, I'd really like everything to be in terms of y. So since I know that y equals x squared, I also know that x is going to be plus or minus the square root of y. And if I'm looking at this piece of it, I can say that it's the positive version. Now remember, to get the entire length of that rectangle, I need twice that. So 2x is going to be the same as 2 times the square root of y. And that will get me my length. So my length is 2 times the square root of y. The width of that representative element, as I said, is going to be dy. And notice I now have an integral. I'm going to be taking these representative elements from 0 the whole way up to 4. So I'll be integrating from 0 to 4. Okay, I have my integral all set up now. I have to evaluate. So let's see. 62.4 times 2 is 124.8. That's a constant that can be pulled out. And so I have 124.8 times the integral from 0 to 4 of the quantity 4 minus y times the square root of y dy. All right. The next thing I'm going to do is I'm going to distribute that y across. So I've got 124.8 times the integral from 0 to 4. And when I distribute it, I'm going to think of the square root of y as y to the 1/2 power. That will make integration a little easier later on. So this will be the quantity 4y to the 1/2 power minus y to the 3/2 power dy. Okay, and now I can begin my integration. So I have 124.8. The integral of 4y to the 1/2 That's going to be 4y to the 3 halves divided by 3 halves, which is the same thing as multiplying by 2/3. Then I'll subtract the integral of y to the 3 halves, which is y to the 5 halves, all over 5 halves, which is the same thing as multiplying by 2/5. And then I'm going to evaluate this from 0 to 4. Okay, so in the first step, I need to plug in my upper limit of integration. So let's see, I'm going to have 124.8 times, this will be 8/3 times 4 to the 3 halves power. And then I'll subtract 2/5 times 4 to the 5 halves power. The next step is to subtract what happens when you plug in that lower limit of integration. But notice what happens. I'm going to have 0 to the 3 halves power and then a 0 to the 5 halves power. That entire expression just becomes 0 minus 0. So I've got minus 124.8 times 0 minus 0. All right, so a little arithmetic. 124.8 times 4 to the 3 halves is going to be 8, so that's 64/3 minus, and 4 to the 5 halves is going to be 32 times 2 is 64, so that's 64/5. And again, I need a little arithmetic here. I think I'm going to pull my calculator out. So I have 64 divided by 3 minus 64 divided by 5, and then I'll multiply that by 124.8. And my result is 1,064.96 pounds. I hope that was helpful. Thanks.